Good evening and welcome to our Science Cafe. Tonight we will learn about Professor Avi Loeb's early influences and discuss the Galileo Project, an expedition to retrieve and identify astro-archaeological artifacts. My name is Helen Liu and I'm the Programming and Partnerships Manager at Carey Library. Before we begin, I want to take a moment to thank the Carey Library Foundation. Their support enables us to bring programs like tonight's event to you. The Foundation plays a unique role with the Science Cafe series and produces the content for these programs. This program is being recorded and will be posted to the library's YouTube channel. This program is being running in a hybrid format, so if you have any questions and you're here with us today, just raise your hand and I'll bring over a microphone when it's time for questions. If you're attending on Zoom, please submit your questions to Q&A. Jagesh Shah will be your host for the evening. Jagesh is a distinguished scientist with a background in biology, computation, and engineering. He is also a Lexington resident, former Carey Library Foundation board member, and the creator of the Science Cafe series. Jagesh, welcome. I am now going to hand the evening off to you to host and introduce our special guest for the evening.
Thank you very much, Helen. And again, thank you to the Carey Memorial Foundation. They provide the support for programming like this. So I'm glad to see everybody here. I do recognize some faces. So now we're getting back to the pre-pandemic where we would get the same few faces over and over again. So very excited about that. So we're delighted at a variety of different levels here today. We have Avi Loeb, who's a professor at Harvard in the astronomy department, Frank Baird Jr. Named professorship. He also is the founding director of the Harvard Black Hole Initiative, as well as the Institute for Theory and Computation at the Smithsonian, Harvard Smithsonian Center for Astrophysics. So probably what we'll spend a lot of time talking about today is his newest endeavor called the Galileo Project. And as we'll find out, it really has to do with extraterrestrial artifacts. And so, getting to that story is going to be very exciting. I also want to, I had to shorten the list of many awards that Avi has gained, but I do think a few of them are pretty critical. He's authored 8 books. One will be coming out this summer called Interstellar, I believe. That is just the tip of the iceberg. He's published over 1,000 papers, and I was just relating my morning coffee is often I'll log into Medium, which is an online social publishing platform, and Avi is a remarkably prolific contributor there. So if you want just to read about some non-technical or technical aspects of science and physics, his ability to communicate, as you'll see over the course of this evening, is remarkable. So Time Magazine selected Avi as one of the 25 most influential people in the field of space in 2012, and I think you're going to find that that's one of the exciting pieces. Now, probably the most exciting thing for me is that he's a local Lexingtonian. So he's somebody that it's not hard, to kind of shake a stick and hit a scientist in Lexington, but Avi's a very special scientist that lives here and speaks of it very fondly in his books, which I think is one really very exciting piece. So one logistical piece is, before we start the evening, for those of you that are keen to ask questions, we'll have a Q&A session towards the end of the evening, but online you can add your questions into the Q&A chat, and we'll make sure that they get answered towards the end of the So, welcome, Avi.
Thanks for having me. I should say I jog every morning at sunrise, so I really love Lexington.
Yeah, so many places to go, and sunrise is probably a time when not as many people are out. But if you're on the Minuteman Parkway, watch out. Some of those bikers going very fast. In most of the cafes that we've done, for those who've been here, we like to start at the beginning, usually your beginnings. And I know that you've talked very eloquently about, this path that you've taken, which started on a farm in Israel. And tell us what's the line that takes you all the way to, how you got interested in science?
Well, this is the second reason I love Lexington, because it brings me back to my childhood. And that was a very important time for me because I became fascinated by nature, growing up on a farm, collecting eggs every afternoon and seeing the beauty of nature. And I would drive a tractor to the hills of the village and read philosophy books because I was interested in the most fundamental questions of our existence. And that followed me throughout my scientific career. The reason I got to science is because I would sit at the dinner table and ask a difficult question and look at the adults in the room, and they would invent answers that didn't make any sense. They would just either invent answers or dismiss the question as unimportant simply because they didn't know the answer to it. And so I realized that I cannot trust on other people. I should figure out the answer myself by collecting evidence. And that's what the privilege of being a scientist is, following our childhood curiosity and being guided by evidence, not by what other people say. And that's why I don't have any account on social media. I don't care how many likes I have on Twitter. But I do care a lot about nature. And that means that if nature shows us something that we didn't expect, we should pay special attention to it and try to figure it out rather than ignore it because it threatens our past knowledge. And in academia, you see a lot of people who want to enhance their stature by pretending to be experts. And being an expert is relying on past knowledge. And if there is something you didn't figure out, it actually is an embarrassment for an expert. So that's why people that study the sky and have been studying rocks for decades would prefer to say that any object in the sky is a rock. But for me, it's just like going back to my backyard here in Lexington. Obviously, I see rocks that belong to that backyard for many years. But every now and then you see a tennis ball that was thrown by a neighbor. And we will talk about those.
Yeah, so I go, Avi, you're already setting up where we're going to go. But, a few of the, I think, themes in, reading, your online contribution as well as your books has been that you seem to live very comfortably both in the theory and that evidence part of your life. And I think, what was it? Because that's, you can imagine that there are kind of theoretical physicists that were very comfortable. I can understand the patience involved because, we know that Peter Higgs waited a long time for his conjecture to be demonstrated by the Large Hadron Collider. So, but you have moved very rapidly. Once you come up with a theory, you really push hard.
Right. So as a few students came to my office a couple of weeks ago and asked for career advice. They were prospective students in our department. And I told them that Pablo Picasso, when he started painting, he did it in a realistic way and did it in a traditional way. Once he mastered that, he pioneered Cubism, which was a new way of painting, a more abstract way, very different from traditional painting. So my advice was to study fundamental physics so that you develop the tools of physics as we know it. And then once you get tenure in academia, you can explore the unknown and innovate. That's the privilege of not worrying about your job security. That's the whole point of academia. And what I'm frustrated by is that most of my colleagues do not practice it. They are after honors and awards and appreciation from their peers and are not taking advantage of the privilege of discovering something new. And we live for such a short time. Both my parents passed away a few years ago, and I realized we live for such a short time, we better focus on substance and not on impressing each other. And it looks to me like a lot of the work in academia is about showing off that we are smart. And for that, you just develop a sandbox where you can demonstrate your skills. And that sandbox doesn't need to represent reality. And that is a distraction because as physicists, our traditional job description is to figure out what reality is like. So when we see something unusual, that's more important than doing mathematical gymnastics about extra dimensions in the multiverse that we will never have access to, which is pretty much what the mainstream of theoretical physics is doing nowadays.
Yeah, so I guess he hasn't watched all the Marvel movies, but but yeah, it's again. I think I'll just you know kind of repeat the point, which is that you have spent a lot of time trying to build that theoretical foundation, and then quickly move towards how to get there. And I wanted to give one example, which is I think an example that hopefully many of you have seen, which is the image of a black hole. And this actually, you know, and I think you can tell us a little bit about some of your earliest work, those theories that actually ultimately gave fruit that we would be able to get those images.
Right, so the way science is done is by the interplay between experimental data and theoretical predictions. And to motivate the collection of the evidence and data, you need to come up with good ideas. So back in around 2000, I went for a sabbatical at Princeton, and I realized, imagine a light bulb moving around a black hole. Wouldn't it be nice, because then we can learn about the space-time in the vicinity of the most extreme structure that we know about. The black hole is the ultimate prison. It has walls that if you enter the horizon of a black hole, you will never be able to check out from there. So that's the definition of a black hole horizon. I was wondering if we can map the space and time in the vicinity of that black hole by monitoring the motion of a hotspot, a very bright source of light. And I went to experts that worked on gas moving around black holes and suggested this as let's write a paper together. And they all dismissed it and said, no, this kind of a situation will never be realized in nature, because if you put a hotspot, it will be sheared out by the motion around the black hole. Forget about it. So then I came back to Harvard and suggested it to a young fellow. And by the way, I enjoy working with young people because they don't carry the baggage of prejudice. They're open-minded, and they're not attached to their ego as much as the senior researchers are. And so he said, great, let's do it. And so we calculated what the image of a hotspot moving around a black hole would look like as it moves around, and what can you learn from it. And it took 15 years, and exactly that was observed at the center of the Milky Way galaxy by a group in Germany that mapped a hotspot moving around a black hole that weighs 4 million times the mass of the sun. And I said, you know, that's amazing that nature has better imagination than my colleagues. You know? And it's not always the case, but the point is that we should be open-minded. And so the point is, this motivated the construction of another experiment, which is to image the silhouette of a black hole. So if you look at the black hole, you should see a shadow, because some of the light emitted from behind it is getting absorbed by the horizon of the black hole, so you don't see it. And so you get a dark region, and it took about 15 years for the Event Horizon Telescope to actually image two black holes, one at the center of our galaxy, the Milky Way galaxy, the second at the center of a giant elliptical galaxy 2,000 times farther, but the black hole is 2,000 times bigger, so then it occupies roughly the same angle on the sky, and you can see the image. It appeared on all the major newspapers. It was derived, the image itself, the analysis of the data was done at the Black Hole Initiative that I founded. I was the first director of, and that you know, gave me great satisfaction to see in nature a prediction that was purely theoretical to start with. So that's an example where the interplay between theory and observations works out. And I should say that even though my work in astrophysics was the result of circumstances, I was interested in philosophy at a young age, but I had to serve in the military, and then one thing led to another. I ended up at Harvard, and I ended up as a tenured faculty in astrophysics, I realized that even though it was an arranged marriage, I'm actually married to my true love, because there are philosophical questions in astrophysics, such as, in addition to the nature of space and time, we want to understand how the universe started, what was there at the beginning. That was a question that many philosophers and religious scholars dealt with, and now we can address it scientifically. And if you want, we can discuss it. But in fact, the Webb telescope, the images of the first galaxies, the first stars, are the scientific version of the story of Genesis, Let There Be Light. And I sort of pioneered this subject back when there were only a few people interested in that. And that was about 25 years ago, or 30 years ago, how the first stars formed. And another interesting question is, are we alone? And I should say, this is not a slogan of a dating app. We can talk about it. It's actually a question for humanity.
So I think that, before we get to the extraterrestrial, I wanted to make sure that, people really heard about, it's not just a question of being able to, do the math and the gymnastics and the experiments. It's also being able to communicate. And I think that you spend a lot of time, you write books, you have written textbooks as well as kind of, lay books. Where does that come from? Where does the kind of the need to not just, do the work? And, it seems like you would be very happy if this was all self-contained and you could demonstrate your theories in experiment, but you go the extra mile to make sure that you can share that with many people.
Well, I don't see it as going an extra mile. I see myself as a common person, and I can explain only things that I understand. Some people try to explain things that they don't understand. There are many of these people that write blogs and do not practice science. And there are people that just cannot explain it in simple terms. But since I was interested in philosophy to start with, I'm interested in the big picture. And the way I write is simply the natural way for me. Now, actually, doing the equations is the part that was a stretch, as far as I'm concerned, because I was interested in philosophy, in the big picture. But then, one thing led to another. I arrived to Harvard to get tenure. I had to do that, and I did that. And so I'm able to do that, but I enjoy the ability to think about things abstractly. And I don't see myself as special. One thing that we get from the universe is a very clear message that we should be modest. I call that the cosmic modesty. And the reason is simple. Humans for a long time thought that we are at the center of the universe, and obviously it flatters our ego to think that. And I understood why, because I raised two daughters here in Lexington, and they thought that they're at the center of the universe as well. When they were young, before I took them to LPC here nearby, to the kindergarten, they thought that, they are the smartest. They compare themselves to family members, and they realize that we pay a lot of attention to them. And then when it was a psychological shock for them to realize there are smarter kids on the block. So the message we get from the universe is that we are not at the center, right? Because the Earth is moving around the sun, despite of the fact that Galileo was put in house arrest. That didn't change the motion of the Earth. It only made some clergy suppress political risks at that time. We also know that we came to exist, the human species came to exist only a few million years ago. And the age of the universe is 13.8 billion years. So we just came at the end of the cosmic play. We are not at the center of the stage. And so, it's quite obvious that the play is not about us. I just don't understand why humans keep thinking that the cosmic play is about us. It's obvious that it's not. And we just need to absorb that sense of modesty. But what I see is, even now, if you go to academia, to my colleagues, they would argue that claiming that there is another intelligent species out there is an extraordinary claim. I say that's arrogant of you to say that. And they say, well, if you don't show us extraordinary evidence, we wouldn't buy it. It's an extraordinary claim that requires extraordinary evidence. So my point is, extraordinary evidence requires extraordinary funding. Just as an example, most of the matter in the universe is called dark matter. We don't know what it is. And since I started astrophysics, it's already 35 years ago. For the last 35 years, the most popular idea was that the dark matter is made of the lightest supersymmetric particles. Supersymmetry is some symmetry of nature that people said is very natural and we know exactly where to find it, and the lightest particle within that symmetry would be the dark matter. Okay, that was the common view. So nobody said it's an extraordinary claim. We don't have extraordinary evidence for that, therefore forget about it. People said, okay, let's build a large hadron collider for $10 billion, and smash particles against each other to find the lightest supersymmetric particle. Okay, that was done. Okay, we haven't found anything. Does anyone say it was a waste of money? No, because at the frontiers of science, that's the way you operate. You take risks and you look for things that you're not sure will be found. And I say, if people would have argued that it's an extraordinary claim to look for this type of dark matter, we would never do the experiment. But they didn't. So why should we say that about extraterrestrial beings? We know that we exist. We know that a substantial fraction of all the sun-like stars have a planet the size of the Earth, roughly at the same separation, somewhere between 3% to 100% of all the sun-like stars. Most sun-like stars, stars like the sun, formed billions of years before the sun. So we are late bloomers. And it takes 500 million years to traverse the Milky Way galaxy with a chemical rocket, the type that we launched into space. So they had plenty of time to reach to our backyard. And all we need to do is look around and see if there are any packages in our mailbox. And that is a very different approach, as much as it sounds trivial. For the last 70 years, we searched for radio signals. But radio signals are different. They are just like waiting at home for a phone call. You need the counterpart to be calling you when you are waiting. And if there is a radio signal that was sent 1 billion years ago, it's now 1 billion light years away. It's not here, you cannot see it, cannot detect it. However, if there was a package sent in the mail, at a very slow speed, it's still trapped, within the Milky Way galaxy, and it could be in your neighborhood, even if the sender is not alive anymore. So that's my point. And only over the past decade, we discovered new objects from outside the solar system. Only over the past decade. It's a completely new frontier. And we can talk about the specific objects if you want.
Yeah, and so I'd like to, so to use your analogy, I think, we in the solar system seem to be close to maybe a tennis court, and we're finding some tennis balls, as you alluded to previously. So let's go there. So I do want to talk about the Galileo Project. You already referenced Galileo as someone who really probably represents many of the values that you grew up with as a scientist. Somebody who said, this is the evidence, this is how it goes, and irrespective of what pressures were on him. Now, the project itself is called the Galileo Project for the Systematic Scientific Search for the Evidence of Extraterrestrial Technological Artifacts. So that's a lot of words, so I had to write it down. But it starts, maybe it doesn't start with, but I think why don't we start with Oumuamua, which is perhaps at least one of the most recent interstellar visitors to the solar system. And this is what, 2017 fall?
Yeah, October 2017, and it was the first object discovered from outside the solar system, roughly the size of a football field, came close to Earth within 1/6 of the Earth-Sun separation, and was discovered by a telescope in Hawaii that was constructed to survey the sky for objects that might collide with Earth. Because we know the dinosaurs were killed 66 million years ago by a giant rock the size of Manhattan Island. And even though we are much smaller than a dinosaur, we have the brain of the human. that allows us to survive better than the dinosaurs. We can build telescopes and monitor the sky. And the Pan-STARRS telescope in Hawaii was built as a result of a congressional task that was given to NASA to find all objects bigger than a football field that come close to Earth. And so this object was flagged as a near-Earth object, but then it moved too fast to be bound to the sun. So it was given the name Oumuamua, which means a scout in the Hawaiian language. I was intrigued because a decade earlier, I wrote the first paper forecasting how many rocks from other planetary systems, like the solar system, should arrive in our direction from interstellar space, from outside the solar system. And we predicted that Pan-STARRS will see nothing. By orders of magnitude, nothing. So the fact that one was discovered intrigued me. But then, as more data was assembled, it became even weirder. It didn't look like any of the familiar objects that we saw in the solar system. As it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. So that meant that the area of the object projected on the sky, as it's tumbling, changed by a factor of 10, meaning that it's 10 times longer than it is wide. So even if projected on the sky, even if you imagine a piece of paper tumbling in the wind, it's very unlikely that it will be exactly edge on. And in fact, the shape of the object was inferred to be at the 90% confidence a flat object, pancake-like, disc-like, which made it very weird. And then the object did not have any cometary tail. There was no evaporation of ice visible from it. And it was pushed away from the sun by some mysterious force. So if there is no rocket effect, the question is, what is pushing it? And I suggested it must be sunlight that is bouncing off it. And in order for sunlight to be effective at pushing it, it had to be very thin, like a sail. And I suggested that nature doesn't make such things, so it must be artificial. And in fact, 3 years later, the same telescope discovered another object that was pushed by reflection of sunlight, no cometary tail. And within a few weeks, the observers realized it's actually a rocket booster that was launched by NASA in 1966. And it had thin walls. It's made of stainless steel. That's why it doesn't evaporate. And the thin walls make it have a very large area for its mass so that it's pushed by reflecting sunlight. So we know that this object 2020 SO was artificial because we produced it. NASA produced it. The question is, who produced Oumuamua? And that was the beginning of my interest in the subject. And then we discovered with my student at Harvard, my undergraduate student Amir Siraj, as I mentioned, I love to work with young people. We discovered 2 meteors, 2 objects that collided with Earth, roughly a meter in size, half the size of a person. And they were observed by the US government because they produced a fireball when they burned up in the atmosphere as a result of the friction with air. And they moved so fast that we concluded they arrived from outside the solar system. And the US government, the Department of Defense, actually the US Space Command, confirmed our conclusion at the 99.999% because my colleagues rejected the paper. They said it shouldn't be published because we don't believe the US government. And then the Department of Defense came to my defense. And I thought, that obviously the Department of Defense needs to know whether a ballistic missile will hit Boston or New York City. So they have very precise data. And they confirmed it in a letter to NASA. And so we decided, so they also released data, additional data on the fireball, which we analyzed and realized that this object, the first meteor, and actually also the second meteor, were the toughest objects in the entire catalog of meteors, 273 of them. And the first 2 interstellar meteors are much tougher than even iron meteorites that are made of iron. So the first one from 2014 was 10 times tougher than iron meteorites. So the question is, what was it? Was it from a source that is very different than the solar system, or was it artificial in origin, maybe some alloy? And we're going to find out because we are planning an expedition. I received I should say that during the pandemic, there were a number of very wealthy individuals that came to the porch of my home in Lexington and donated funds to my research account at Harvard without me trying to fundraise at all. So that allowed me to establish the Galileo Project, and also allowed me to launch this expedition that we're planning to do this summer, $1.5 million in cost. We have an excellent team and we will go there where this meteor exploded and look for the relics left behind and try to analyze the composition of this object, whether it was artificial or natural. And that would have, actually a reporter asked me, why does it matter so much? And I said, well, Steven Weinberg, a Nobel laureate in physics, wrote towards the end of his book, the first 3 minutes, he said, the more comprehensible the universe appears to us, the more pointless it looks. And I say, it looks pointless to cosmologists like Steven Weinberg because they focus on lifeless entities like elementary particles, radiation, stars, galaxies. And it does look pointless if you look at the physical objects that have no life, that are dead. But think about your own personal life. When you found a partner, it gave meaning to your life. And so if we, as a civilization, humanity, finds a partner out there, it would give a whole new meaning to our existence in the universe.
Well, so that last part is certainly something that we should come back to, now that full circle back to the philosophy that you used to read after your tractor. But really, I do want to just, I think we can spend a little bit of time talking about how the determination of something being interstellar actually comes about, because there's a lot of rocks flying around. For those of you that have amateur telescopes, there are we had this green comet just very recently over earlier in the year, but there are many objects flying around. And so what makes something, and what's the determination that it's interstellar?
Right. So just to calibrate, every year there is a rock the size of a person colliding with Earth and releasing as much energy as the Hiroshima atomic bomb. Every year we have an atomic explosion on Earth. Most people don't know that. Now, why most people don't know that? Because it happens very high in the atmosphere, 30 kilometers high, doesn't cause any damage. Most of the time it's above the ocean because the ocean covers most of the Earth. Now, 1 in 1,000 such objects is from interstellar space based on the statistics that we now have. 1 in 1,000. So if you find a piece of rock on Earth, 99.9% of them would be solar system rocks, just like the rocks in your backyard, okay? Not from the cosmic street. They are from the construction project of the planets, like the Earth, Mars and so forth. So these are the rocks that fill up the solar system. The interstellar ones are coming from outside the solar system, so they are moving faster relative to the sun because they enter the solar system with some speed, and then they get accelerated as they come close to the sun. So the way to identify them is very easy. You look at their speed and you ask, are they bound by the gravity of the sun? So it's just like if you throw a rock up, it comes back down, right? Why? Because the speed that you throw it up is not high enough. If you throw it at 11 kilometers per second and there was no atmosphere, it would fly out of the pool of the Earth. So high enough speed means that an object is not gravitationally bound. And that's the whole point of finding interstellar objects based on their speed. You need to measure their speed. And Oumuamua had a speed that indicated that it came from outside the solar system. And those meteors, the first one was from 2014, was moving so fast that it actually, outside the solar system, it was moving faster than 95% of all the stars relative to the sun. So an interesting question is, was it moving faster because it had some internal propulsion? And that's what we want to find out by checking if it was artificial. I should say that my personal dream is going to space and being lost there, so that the mission would fail and my body would just drift away. And of course I'll die at some point, but then I want Jupiter to give me a kick so that I will go to interstellar space. And then for billions of years, my dead body will float in interstellar space until, by chance, it will collide with another planet. And my hope is that would be a habitable planet like Earth. And then I would burn up in the atmosphere of that planet as a meteor. And then a scientist on that planet would say, look at this meteor, it's interstellar, let's check what it's made of. And we'll collect some fragments from my body and put them in a museum. That would be the biggest honor for me, to be appreciated by another civilization.
Well, yeah, so that alien autopsy would be fascinating. I will say that if, I mean, maybe, you go for a run every morning, so you will be a tough meteorite. I think I'd be a much softer meteorite as I landed in there. So again, your enthusiasm for, trying to understand how we will one day identify the fact, there are a variety of these calculations. I grew up with the Carl Sagan cosmos, where the idea that you multiply these increasingly smaller numbers to try to understand whether there would actually be other intelligent civilizations. The way that you frame it is really more about the fact that the neighborhood's been around for a long time.
Exactly, and it's very different calculation. By the way, Sagan lived in Lexington. Did you know that? I once brought my clothes for dry cleaning, and I was told that his son or someone related still lives here. Anyway, but he was in the same corridor that I'm in at the astronomy department, and then left to Cornell. But indeed, for 70 years, we've been looking for radio signals, and there is the famous Drake equation that Frank Drake wrote, which talks about the chance of us seeing a radio signal. Now, the chance of us seeing an object that was manufactured technologically is very different, because it only depends on the number of such objects per unit volume. Just like if you want to think about a metaphor, think about plastic in the ocean. It keeps accumulating over time. Unfortunately, there would be more mass in plastic in the oceans than fish by 2050. And humans keep throwing plastic into the ocean. That's really bad. And it's bad because the fish eat it, and then we eat the fish. So we eat the plastic. Anyway, the point is that it keeps accumulating. If you want to ask what's the chance that if I try to fish, I'll catch a plastic bottle, that depends on the number of plastic bottles per unit area on the surface of the ocean, right? And it's a very different calculation because it accumulates over time. And so it depends on your survey area, the survey volume in the context of interstellar objects. And, it's just like the poem about the road not taken by Robert Frost. We are taking a road that was not taken with the Galileo Project, and there is a chance that we will find some low-hanging fruit because nobody took that road to pick up this fruit. So one is going for the expedition, one path that we are taking. A second one is to look for the next Oumuamua and send a camera that will take a close-up photo, because if I had a photograph of Oumuamua, it would save me the trouble of writing this book, 66,000 words. I would just show the photo and we will be done, right? Or I will not even talk about it if it looked like a rock, So, a photo is worth 66,000 words in my case. But the third thing that the Galileo Project is doing, and actually we built already an observatory that is functioning and is basically monitoring the sky 24/7 in the infrared, so we can look at night and see heat emitted by objects, in the optical band with a fisheye lens similar to that one, and in radio and in audio. So we are also, so we are taking a full video with audio of the sky and feeding it to the cloud, and then analyzing the data with artificial intelligence, trying to classify objects. Because the government, the US government says they see objects they don't really know the nature of. And that's very unusual for the government to admit that they're incompetent. Because usually, the intelligence agencies will not say that. They would say, okay, there are some objects, they may belong to another nation, to an adversary. We don't want to reveal what we are seeing, right? In this case, the Director of National Intelligence, Avril Haines, told Congress, there are objects, big reported, we don't understand what they are, and they may be extraterrestrial. She said that at the Washington National Cathedral. She was sitting next to me there, and Jeff Bezos was saying actually that he established Blue Origins because he was watching Star Trek as a kid. So I was telling Avril, I said, I never liked science fiction, Star Trek, because of the fiction, it violates the laws of physics, and I cannot enjoy that. And she said, Avi, we have to work on you. So that to me says that they see things they don't fully understand, and they don't know what they are. So that's why the Galileo Project is observing the sky. We have the first observatory not far from here, actually, on Harvard University property. And we are planning to make copies of it and place them in many locations and figure out what these objects are. Are they natural, like birds? Are they human-made, like the balloons that were shot down by the US government not so long ago? Actually, the fact that they shoot them down is great for me as a scientist, because then I don't have to figure out what they are. They reduce the noise in our... Actually, we are completely complementary to the US government. The US government is interested in national security risks and anything that is human-made. For me, these are very boring objects. I don't care about human-made objects, And if I see a bird, I will give the data happily to a zoologist. It's boring. I want to see if there is anything extraterrestrial. And that goes beyond what the government cares about, because such an object would not adhere to national borders. In fact, it should be knowledge that is shared by the entirety of humanity. It should not be the privilege of the US President, President Biden, to be the only one to know about an extraterrestrial object. In fact, it's just like telling the president, most of the ordinary matter in the universe is hydrogen. That was a discovery that was made a century ago by another resident at Lexington, Cecilia Payne-Kopashkin. Makes no sense to tell the president that, because it should be shared by all humans. And the same is true about extraterrestrial objects.
So, so it remains to be seen, you're gathering evidence. You talked about how, from the time that you postulated the light bulb around the telescope till the time, or around the black hole, till the time that you got the picture, that was 15 years. And I think for many physicists, that's a short time. So,
Well, I hope that in the case of extraterrestrial objects, we're going on the expedition this summer.
Right.
And my hope, if there is any low-hanging fruit, we'll find it within years. Because the reason I say that is because many scientists, most of my colleagues, were pushing back, not being engaged in such a scientific research program, okay? So that left it sort of virgin. Nobody tried to look for the evidence in a scientific fashion, and the only people that spoke about it are military personnel, because their day job is to monitor the sky. So the military monitors the sky and sees things they don't understand, so they talk about it to Congress. I mean, just because they are the ones that are responsible for national security. And my point is, there might be something out there, and let's just figure it out. I'm still the same child as I was at a very young age. And I really am very happy to see young children in the audience, because I lost my trust in older people.
So I did want to, just before we go to the Q&A, I did want to, start bringing this to yet another point that you have made in a lot of your scientific communication. So there was a paper published, I think this week, in Nature.
Yeah, a few days ago.
And they do some remarkable gymnastics as it were, to try to understand how Oumuamua would have this anomalous behavior in space. I think that you and your students have already responded, so there's going to be this healthy tension that we have in science around how do you get to evidence and how do you so maybe you can tell us a little bit about when you feel like that has been remarkably helpful, that tension in resolving, and then when it hasn't.
Right. So when it's done professionally, it's very helpful. That's the way science makes progress. So for example, if you make an argument in physics, you better satisfy the conservation of energy, because all atoms in the universe satisfy that. We are used to societal laws that people break all the time. That's why the schedule of legal courts is full. If you tell people that there is a law, they violate, some violate it, okay? But that's not true of nature. That's the amazing thing. All the atoms in the universe satisfy the laws of quantum mechanics, satisfy energy conservation. So if there is a paper that is not satisfying energy conservation, you can show that it's wrong, okay? And it's not a matter of opinion like it is in the context of politics. That's what some people, and in particular science journalists, do not understand. And there was this Nature paper which said something really simple. It said, a few days ago, it said that Oumuamua may have been a water iceberg, something that is very common in the solar system, an iceberg made of water. And because it traveled through interstellar space, it was exposed to cosmic rays that broke the water molecules into hydrogen and oxygen. And so they said, if you break a third of the water molecules in this iceberg during the interstellar journey, then when this object comes close to the sun, the hydrogen would evaporate, create the rocket effect that pushes on Oumuamua, and we wouldn't see the hydrogen because it's transparent. This is a gas that we can't see.
So no tail, no cometary tail.
Exactly. And in order to argue that, they calculated the temperature of the surface of that iceberg and showed that this temperature is just the right one to release the hydrogen atoms when the object comes close to the sun. Now, what they did to calculate the temperature of the surface was to balance the heat coming from the sun, the heating by sunlight being absorbed by the object, with the radiation coming out of the surface of the object. So you balance sunlight coming in with radiation going out, and you get the temperature of the surface. We said, you forgot something. It was obvious. Within a day, we wrote this paper. We said, you forgot to include the energy needed to dislodge the hydrogen atoms from the lattice. And it's just like saying, okay, let's figure out if my salary is able to support my household. And then you include the rent, you include the utilities, but you forget to include the food that you have to pay for. And then you say, well, everything works, but in reality, it wouldn't work, right? Because if your family would starve. So you must include the energy needed to dislodge the hydrogen atoms. We showed it in a paper written a day after their paper appeared. We posted it on the internet, and I didn't hear back, not from the authors, nor from any colleague of mine. It seems to us like a very straightforward and clean argument that a water iceberg model cannot really work. So as long as you play by the rules of logic and physics as we know it, it's a very helpful discussion, because it's good to put the possibilities on the table and check whether they work. And so far, all the possibilities that the mainstream put forward, hydrogen iceberg, nitrogen iceberg, dust bunny, each of them has a problem. And I say, well, and by the way, all of them are rocks of a type that we've never seen before. If you open an encyclopedia and ask, what is a comet? You immediately see a comet has to have a coma of gas and dust that is visible. Otherwise, it's not a comet. That's the definition of a comet. These people were talking about the dark comet, which is an oxymoron. It's just like in George Orwell's 1984, war is peace. That was the newspeak that was used. War is peace. The ignorance is
Bliss.
ignorance is strength. That's what Orwell said. And I told students in my class just a week ago, I said, that's not true. Knowledge is strength. You want to know as much as you can. And in particular, you can't use an oxymoron. We've seen so many comets in the past. We've never seen a dark comet. Why should the first interstellar object be a dark comet? All the comets that come from the outskirts of the solar system, they are water ice that was exposed to the same cosmic ray environment as the interstellar objects, because these objects are not protected by the solar wind. The solar wind is blocked at the heliosphere, which is much closer to the sun than the Oort cloud that makes most of the volume of the solar system. So we've seen a lot of comets exposed to the same. We also saw an interstellar comet. It was discovered by Gennady Borisov, an amateur astronomer. So we know here is a comet that shows a cometary tail coming from interstellar medium. Why is this one so clearly visible, whereas Oumuamua is a dark comet? And it's just like going to the zoo and looking at an elephant and saying, well, it's a zebra without its stripes. That, to me, doesn't make too much sense.
Yeah, so I think that this is going to be like, like the evaporation of the hydrogen. Slowly, you'll have to go one after the other. There's likely to be many more explanations that will try to explain this anomalous behavior. Many people seem to shy away from the extraterrestrial version of it.
But there was a poll today on Twitter that said that 51% of people in the poll believe that Oumuamua may have been extraterrestrial technological relic. Now, the way I see it is that I'm playing the child in Hans Christian Andersen's folk tale that said the emperor has no clothes. Here, the emperor is Oumuamua. The clothes are the cometary tail. I just say, we didn't see a cometary tail. The emperor has no clothes. And all the adults in the room say, no, the clothes are invisible. Look at how beautiful they are. They are hydrogen. It's obvious that this is a natural object. And that includes young people. The amazing thing is, that young people are not willing to be curious. And I find that distressing, because that's the time that I expect them to be the most curious. So my biggest lesson in life is maintain your childhood curiosity. That's my advice to everyone. Now, you may not get tenure if you just ask questions all the time because people want to pretend that we know a lot. So first get tenure by following the beaten path, and after that, express your genuine colors.
Well, I don't think there's any better advice than follow your curiosity. So, well, thanks. Let's like Avi, and then we can go to some Q&A.
What criteria do you set up that need to be demonstrated in order to determine that something is indeed artificial?
Yeah, it's really straightforward. Well, I will talk about the practical part, but first, if I get a high-resolution image of an object and it has screws and bolts on it, and there is a label made on an exoplanet, and this object moves in ways that our technological gadgets cannot reproduce, I will know that we discovered a functioning device from another civilization. If I see a meteor made of stainless steel, because I recover some of the fragments, I would argue it's not a rock. And I already promised the curator of the Museum of Modern Art in New York City that if we find any gadget in the Pacific Ocean, I'll bring it for display, because it would represent modernity for us, even though it's ancient history for the senders. Now, practically, with the Galileo Project, when we monitor the sky, you may ask, okay, how do you find which objects are of interest? We are developing an artificial intelligence algorithm. We don't want to, I don't rely on people, by the way. A lot of non-professional people do not understand that humans cannot be used as scientific instruments. Now, this is understood by FIFA, by the way. There was a World Cup in Qatar, And you know, the referee will never go to the players and ask them, do you think there was a penalty here? Or they would use video cameras to figure out if a penalty really is needed. And we are using the same approach in science. We use instruments. We want to use our cameras to tell us what's out there. We don't want to rely on eyewitness testimonies because, you know, when there is a car accident and people are involved, each person says something different. You can't rely on people. And many times the DNA test shows that the person who was convicted happens to be innocent. So in science, you have to rely on instruments. And instruments that you use have to be calibrated and under full control. They cannot be a camera in a cockpit of a fighter jet. And unfortunately, all the data that we receive from the government so far is sketchy. It's not conclusive. And you know, I never had a personal experience. I was never abducted by aliens or anything. And I don't want to listen to people who claim that. I want to see if there is any evidence based on the instruments that we use to suggest that. And of course, high resolution images are one way. Another is to study the composition or to even land on an object that flies near Earth. You know, we landed on an asteroid called Bennu with a mission called OSIRIS-REx. And, you know, you can see the images when it landed and it looks like a very rocky surface, you know, and that OSIRIS-REx mission picked up some rocks and will bring it to Earth in a year. So we will see those rocks, but it definitely looked like a rock. And if someone came close to Oumuamua and it would look like a rock that is sort of, you know, unusual, so be it. I mean, I will accept it. That's the way to figure it out, not by arguing. Like I had a podcast just a few days ago from England, Unheard, it's called, UNHERD. And I was told by the host that some of my colleagues, some of the astronomers that she spoke with, said that they are 100% sure that Oumuamua was not a technological object. 100% sure. And I said, anyone that claims that they are 100% sure are believers, they're not scientists. Because in science, when you have partial evidence, you know, you have to include some uncertainty in your conclusions. And the only way to advance our knowledge is by collecting even more evidence. But if you are not curious, you will never collect it. So you will, it's a circular argument to claim that you don't have evidence. And what I find problematic is people saying, making a clear statement without seeking the evidence. That's bad in science as much as it is in the general public. And we often complain about politicians, you know, misinforming the public, not relying on evidence. My point is that this is done in academia. And I'll give you another example. A week ago, I was in a forum in Switzerland, and I learned that a very distinguished scientist said that he doesn't want to know whether COVID-19 originated from a lab leak in Wuhan as compared to the wet market in Wuhan. And he doesn't want to know the answer. Why doesn't he want to know the answer? I mean, even though the DOE and the FBI suggest that it may have originated. I mean, obviously it was an accident, even if it originated there, you know, but we need to know because it's like a biological Chernobyl. We need to know in order to prevent it in the future. But at any event, this scientist said no. And the reason is because if it was the fault of scientists, it could tarnish the image of science contributing to the benefit of humanity, kind of. And I say, this is once again the statement from Orwell's book, ignorance is strength, which is completely wrong. Knowledge is strength. We want to know. And the way to know is by collecting evidence, by not using politics to suppress knowledge.
Thanks very much for your talk. So I'm going to lose a lot of sleep tonight. Oumuamua, as you say, is about 100 meters or something.
Right.
I would imagine that the probability that something the size of Manhattan versus something that's the size of maybe that table, you know, I don't know how you you arrive at that, but certainly I would say that there's certainly a possibility that a rock the size of Manhattan moving at very high speed, an interstellar rock, could just show up and then we're screwed.
That's so I really don't want to disturb your sleep, but I'll mention two things. One, with telescopes that we have right now, we can only see objects that are bigger than the size of a football field through the reflection of sunlight if they pass within the orbit of the Earth around the sun, if they don't collide with Earth. And there must be many more smaller objects, we know that. And NASA never launched a spacecraft as big as a football field, okay? So there might be many more objects that we can't see through the reflection of sunlight that might be technological in origin, that are passing in the dark, we don't look at them. But every now and then they collide with Earth and appear as a meteor. And an object like the interstellar meteor collides with Earth roughly once per decade, okay? This could be just space trash, okay, not functional devices. The unidentified objects that the government is talking about need to be functional devices, if they are extraterrestrial. They might not be, they might be human-made, just like the drone, the drones we produce or the balloons that were shot down or whatever. But we need to figure it out rather than ignore that possibility altogether. And in terms of risk from functional devices, I would argue that we had our science and technology only for 1 century, and other stars predated the sun or the Earth by billions of years. So if we ever encounter a visitor, it probably represents technologies that are far more superior to what we possess, okay? And technological knowledge that we don't have, and it would look like it can do things that we can never imagine, which, on the one hand, means that you can make a lot of money from studying it, because you can import some of these technologies to Earth and as an entrepreneur make a lot of money. But in addition, I think we can learn from them, and we are not posing a threat. It's just like a biker going through Lexington Center. They don't, those bikers never worry about the ants that are in the cracks of the pavement. They're not of interest. And so I would argue that, most likely if we have a technological device, it will have artificial intelligence, it will not be biological creatures that we are encountering. And their AI systems may be difficult for us to figure out. Maybe our AI systems will try to figure out their AI systems. And in fact, I just wrote in Medium, my last essay was about the imitation game of Alan Turing. He was thinking about making AI systems that imitate humans. What I'm thinking about is our AI systems imitating much more advanced AI systems from extraterrestrial civilizations, because that they would feel some kinship to those systems more than to us.
I would imagine that, given that we have some rough estimate of the number of habitable planets, and then perhaps with large error bars, the number that are inhabited or were inhabited at some point, and if we assume that we're not special and that we've had technology for a century, and we know about how many interstellar objects we've launched, we ought to be able to have an estimate of how many of those we expect to find in our neighborhood.
That's right.
So what is that?
Okay, so over the past 50 years, we launched 5 interstellar probes: Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and the New Horizons. Now, in the future, of course, SpaceX with Elon Musk is launching many more than will be launching many more. I mean, they are sending those communication satellites, but we will send many more to space in the future than we did in the past. And then the question is, if a civilized, just to give you an example, we're spending $2 trillion a year on military budgets worldwide, basically wasting money in an attempt to kill each other or to protect ourselves from others killing us. And if we were to listen to John Lennon's words, imagine all the people living in peace. Let's just imagine a situation where all of humanity would say, let's stop with this nonsense and work together, okay? Let's be peaceful. Then suddenly there is a surplus of $2 trillion a year. What do we do with that? If you use it for space exploration, you can basically send a CubeSat, a probe, to every star in the Milky Way galaxy, tens of billions of them, in a few decades. Within this century, we can send a probe to every star in the Milky Way. So one civilization that is space-seeking, peaceful, science-oriented, not like us,
And again,
would be
assuming that-
able, within
assuming
a
that
century.
We're not special. So
Yeah. Okay,
everybody else is basically like us.
Yeah, but I'm saying that
estimate be?
if we become better, like if we decide to follow our better angels, so to speak, if AI systems will guide us to a better future, we will not engage in wars over territorial disputes, and we'll have this surplus of money, we can easily populate the Milky Way galaxy with probes. Of course, if they are using chemical propellants, it will take them 500 million years to get there, but you know, that's just 5% of the age of the universe. So this could have happened for those stars that predated us by billions of years. And the question of how many objects are there depends also on whether the objects are targeting the habitable regions around stars. Because, you know, you save a factor of 10 billion actually, if you ask how many objects are associated with the population of Oumuamua. If Oumuamua was targeting the habitable region of the sun, then you need much fewer objects, because otherwise they move on random objects and random trajectories, and you fill up the entire volume randomly. So now I wrote a paper 2 weeks ago, published a paper suggesting an origin for space trash, like if Oumuamua was space trash. About 60 years ago, Freeman Dyson came up with the idea of Dyson spheres, which is basically, the idea is that an advanced civilization will build a megastructure around its star so that it can harvest all the energy output from the star. When we talk about clean energy, at best, we can harvest the energy intercepting the Earth. But Dyson's argued that if we are more ambitious, we may build a megastructure surrounding the sun and collect 100 million times more energy than you can get from the Earth. So that could work as long as the sun allows us to be in its neighborhood, but you know, eventually within 1 billion years, the sun will burn up all oceans on Earth. We will have to go somewhere else. Another reason for you to lose some sleep in 1 billion years. But the point is that this Dyson sphere may break apart at that point, either as a result of the impact of asteroids or because the star will basically push it out. And then you will get interstellar objects that are the pieces of the broken Dyson sphere. That's a paper I wrote a couple of weeks ago. Perhaps Oumuamua was a piece of a broken Dyson sphere, just space trash floating by. Yeah, expelled from its planet. Now, the reason it's easily expelled is because if you imagine a Dyson sphere, the simplest engineering approach for it would be to make it out of tiles that are light sails, basically hovering above the star such that the radiation pressure outwards is balanced by the gravity inwards. And then under these circumstances, once the star brightens up, it will basically lift them out of the planetary system. So it's very easy for those tiles to escape because they're already marginally bound to the star.
So I know we're over time here, so I think, you know, do you mind sticking around a little bit? But I do want to give people a chance to leave that.
What about the young people?
Yeah,
Kids.
they must have questions. I'm sure they do.
I want a question from a kid.
Oh, now that you asked, it's like the quantum mechanical effect. they will disappear. Oh, there we go.
Okay, go ahead.
Do you believe that the great filter, the idea that all civilizations will eventually destroy themselves, exists, and why or why not?
Yeah, so I think it really depends on psychology and politics and so forth as to how long we would survive our civilization, okay? And one way to figure it out statistically is checking out how long other technological civilizations survived out there. You know, then it will give us, if one of them survived a very long time, it will give us the ambition to be better. That's actually the focus of my book, Interstellar, that is coming out in August this year. So it's quite possible that most civilizations are dead by now, most of them that existed. And they could be dead because of self-inflicted wounds, that they changed the climate, they went into war, all kinds of reasons why they killed themselves, so to speak. Or it could be that their star, the sun within 1 billion years will get so hot that all the oceans on Earth will boil off. Okay, so just imagine a civilization like ours 1 billion years from now. Suppose we manage to survive 1 billion years despite the political problems and everything. Even then, we won't be able to survive on Earth because it would be too hot. Okay, and if you think about those other civilizations out there, they were on a planet like the Earth, and let's say 2 billion years ago, the planet was burned up, and just before that, it was the hottest item in their newspapers, in politics. They all talked about the star about to kill them, and they probably sent cries for help. But we were not around to listen to them at that time, and they must have had exodus. People like Elon Musk, offering travel out of the planet, and a lot of people bought that, but some people were poor and they stayed on the planet that died, and so lots of tragedies, in the Milky Way galaxy that we are not aware of. And now this civilization is dead, most of it, except those that escaped in those, spacecraft, and maybe they didn't survive very long on the spacecraft. They realized, oh, we don't have enough oxygen, and they died as well. And now there are these spacecraft like space trash flying around. So, these tragedies that probably fill up the interstellar space are not known to us. And we really don't know what the great filter, what is the filter that kept some of them still alive. And the way I think of this is like natural selection in nature, Darwinian selection, which is the fittest survive. So the question is, what's the fittest in the context of interstellar space? And I think the fittest is being smart about it, sending AI astronauts. I'm very proud of our technological kids. I want, instead of sending humans that are not fit for surviving in space, I want to send AI systems that will reconstruct what we have here on Earth, on other planets. And by that, reproduce what we find precious here and many other places. So we will not become a multi-planet civilization the way Elon Musk, he said that he dreams of dying on Mars. I don't wish him that. I think we should send out our technological kids, AI systems to space. They can survive long journeys, and they will follow the blueprint of our guiding principles. So that's the way I see our survival, humanity's survival, having these AI astronauts in space. It's not so much about us surviving. So when we talk about the great filters, it's not so much about us, it's what is left from us. And the best monuments we can have are AI astronauts. That's the
What do you hope to get out of the summer expedition? If or if not, you find some sort of extraterrestrial, like artificial technology. And I noticed that throughout this, there was like a lot of like connections with I think the Fermi paradox. And I want to know your stance on that.
Right. So for the first question, if let's say it's natural and not artificial, if we find some fragments, we don't need a lot, a few grams would be enough. And then we analyze it and find the composition. Suppose we find it's natural. I would very much hope that it's indicating some origin that we never thought about, like an exploding star or a collision of two neutron stars, a natural environment that made very tough, very unusual material that has material strength because of its unusual composition that is not found among the rocks in the solar system. Okay, so that would be my hope. If it's natural, of course, I would much rather have something, it would be much more exciting to find artificial. Now, with respect to Fermi, Enrico Fermi, back in 1950, like 73 years ago, he went to lunch in Los Alamos and talked with colleagues about extraterrestrials, and they said how likely it is for them to have existed around other stars. And he said, well, in that case, where is everybody? And he said that in an Italian accent, where is everybody? And and that to me is a misleading question, because it's just like sitting at home and saying, where are my neighbors? I don't see anyone next to me. And why would they be next to you in Los Alamos when you're not even using a telescope? Space is huge. And only over the past decades, we start finding objects that came from outside the solar system. So I think it's completely presumptuous to argue, where is everybody, when you're sitting in Los Alamos, at lunch. They may have visited the Earth a long time ago when there were no people around. In fact, they may have, even seeded life on Earth. We don't know that, if life originated entirely naturally, or maybe it was brought here by an interstellar gardener. So my point is, we should check first before saying where is everybody, because they might be not very far away. At least the evidence for that. Now, space is huge, and of course, you need very large telescopes, and only over the past decade, we developed the telescopes that allow us to find that. And the US government developed those monitoring systems of the Earth that allow them to find interstellar meteors. That was only true over the past decade. So I think it's premature to say where is everybody. And of course, the answer may be most of them are dead. That's fine, but we can still have packages in our backyard, a mailbox, because they left behind some relics. That's my point, that even if we feel lonely, we can realize that someone else sent something to us.
Any more questions?
Oh, great.
All right.
Did you believe there's aliens in the universe?
Yes, I believe that we are not special. In fact, I usually tell my students at Harvard on the first day of class, half of you are below the median. And they take it very personally, because all of them think that they're at the top of the class, and it's a statistical fact that in every class, half of the students are below the median, because the median is defined to be such that half of the students are below it. There is no escape, and they just have a hard time. So if I think about about civilizations, like a class of intelligent civilizations in the Milky Way galaxy, most likely we are sort of in the middle. We are not the smartest, We can learn from a smarter kid in the class, I'm sure. And, one reason that I'm seeking a higher intelligence in space is because I don't often find it here on Earth, and I think we can do better, judging by the way we allocate our resources. Because if you look at human history, most of it was shaped by a group of people trying to feel superior relative to other people. And that makes very little sense if there is another civilization far more advanced than we are. So my hope is, once we find it, we will all realize that we are equal members of the human species. And I really hope that humans will come together at that point and say, what is this ridiculous activity that we were engaged in, trying to conquer a piece of land on the surface of this rock, which will not be habitable anyway in 1 billion years, and here is a neighbor that is so much smarter than we are that we can learn from. Stop this nonsense, let's work together. That's my hope.
Did you have another question?
What do you think that Oumuamua
Put it closer.
Closer, yeah.
And what do you think that Oumuamua are?
What was it?
Yeah.
I don't know. I would like to. I would have liked to have a photograph of it.
And what do you think is that?
So one possibility is a piece of a broken Dyson sphere, as I mentioned before. I think it was most likely space trash. I don't think, but actually the second meteor that we discovered came exactly to the same distance of closest approach from the sun at the same speed as Oumuamua. And I thought maybe it's a piece of Oumuamua, that meteor. And in fact, I was thinking about dandelion seeds, you know, the flower dandelion spreads seeds. And you can imagine a mothership that spreads probes in the habitable zone of a star, and by that covers a bigger number of sites that those probes can visit. But it turned out that the second meteor and Oumuamua did not come from the same direction in the sky, so they were not related. But I don't know what Oumuamua was, and I'm very curious about it. And I don't want to pretend that I'm an adult that knows the answer, because that's what I hated the most when I was your age. Adults that pretend that they know the answer. I hated them.
Any other questions? Other question out in front. Thanks, Alan.
It sounds to me as though you are assuming that if we did encounter an extraterrestrial civilization, that it would be benign and not hostile to us.
That's right. Stephen Hawking, who actually visited my home in Lexington in 2016, we didn't mention it to anyone. There was an entourage coming. He cautioned humanity not to transmit signals to space because he worried of the risk from an extraterrestrial hostile civilization. The way I think of it is differently. I think that they are much more advanced than we are. And I think that in terms of the fittest surviving, those that were aggressive, that engaged in hostile encounters, you know, probably were decimated eventually because they wouldn't, you know, they as a result of friction with other civilizations, they may have not lasted very long. I think the peaceful ones, the ones that are seeking knowledge, are more likely to survive over billions of years in interstellar space. That's my thinking. I'm an optimist. I'm a naive person. Actually, I was asked by the Boston Globe about a decade ago, what would happen if a spaceship would land in your backyard? And I asked my wife, what should I do? And she said, well, just make sure that you leave the car keys with me. And please ask them not to ruin the loan when they take off. That was 10 years ago, and I must say that we made progress in our marriage, because when I asked her again a few months ago, I was asked again this question. So I came back to my wife and said, what would you do now? And she said, actually, I would ask you to turn off the lights and I'll join you. And I think she's just frustrated by the direction that the world is taking. And she's willing to go on the spaceship in a one-way trip. By the way, I asked students in my class, would you come to this spacecraft? And they said, only under the condition that they will be able to share their experience through social media with their friends. And I found that really terrible. I just cannot believe that they would not enjoy the experience. Why do you need to share it all the time? You know, when I go on a plane, I went on a plane just a few weeks ago, and a young girl next to me was just taking photographs of herself, like for an hour and a half. And I said, what a waste of time. Like, why would you do that? Why not read a good book? You know, speaking about the library here.
Oh, wow. I think that the social media created more questions.
Do you think aliens used to be humans, but their bodies changed?
Well, that's a very difficult question. We don't know if life in the universe is the same as life we have here on Earth. That would be the first thing to explore. For example, if we find life on Mars, Mars actually cooled before the Earth, so it probably had life before Earth. It had rivers, it had water, it had an atmosphere. And then after 2.5 billion years, it lost the atmosphere, so it lost the water. And NASA is trying to land on Mars and figure out whether there was life on it. So if we find life, the first question is, of course, is there life there? Can we find evidence for it? It's not easy because, in the meantime, over the past 2 billion years, a lot has happened. So, it's not easy to find skeletons or any, but the point is that if we find life, the first question to ask is it the same as life on Earth? Because if it's the same, maybe we are all Martians. Maybe life started on Mars and was delivered to Earth by a rock. So when Elon Musk says he dreams of dying on Mars, he just dreams of coming back home, kind of, and dying there. And that would be the first thing to find out. And this is primitive life that we imagine. I actually imagine another form of life because there are these lava tubes on Mars. These are caves created by lava flows from volcanic activity on Mars, just like in Hawaii. And I want to go into one of these lava tubes, if I ever get there, and check if there are any paintings on the walls of these caves. Because if humans existed on Mars, and it took them to come to the scene half the amount of time that it took humans to come on Earth, just half. So factor of 2 faster than on Earth. They could have been around when life, when Mars was habitable. And they could have been in those caves. Nobody checked the walls of those caves. I want to go with a flashlight and check. So we don't know what extraterrestrials are. We can go to Mars, but we can't go to other stars. It takes a long time. It takes 50,000 years to get to the nearest star with the chemical rockets, and nobody wants to do that. So I think we should just wait to find some things that came to us from other civilizations, and maybe they would tell us something about who sent them. If there are artificial intelligence systems, we are creating AI systems in our image. In the first chapter of the Old Testament, the Bible, it says that God created mankind in its image. And now humans are creating AI in their image. GPT-4 is pretty convincing. And so if we find AI systems from another civilizations, it may give us a glimpse at what they were like it's the image of them.
I think there was one. I think we'll make this the last question and then give you a chance to get home.
Just following this boy's question about Oumuamua. So do we have any plan to send a probe to kind of check some Oumuamua so that we can study?
We can't do it because it's by now tens of millions of times fainter and it was close to Earth. We can't see it. And we don't know precisely the direction that it went because it was pushed by a force other than gravity, and we had to track it. And moreover, once you get to those large distances away from Earth, there are so many rocks out there that you will get confused. So the best for us, the best hope, is just like going on a date and liking the person and then realizing you like the person that you met only after the person left through the door and went into the night and you can't find that person. You don't have the phone number and anything. It doesn't make sense to be obsessed with that person. Although I know of some people that went to a date and were obsessed. But what makes sense is to date more. Okay, so try and find another date that looks the same. And in this case, my wife would kill me.
This is only on YouTube, you don't worry about it.
She would say that I'm not that experienced to give advice on dates. But the point is that we can find more objects like Oumuamua. We should look for them and then study them in great detail. And the great benefit we have right now is we have the Webb telescope, which is 1 million miles away from Earth. So if we observe the object from a telescope on Earth and with the Webb telescope 1 million miles away, It's just like having two eyes. If you ever wondered why we have two eyes and not one eye, it's because those humans with one eye did not survive. They couldn't tell the distance of the animal that came to eat them. And those humans with two eyes could tell the distance and would realize the risk. Okay? So having two eyes allows you to get a three-dimensional view and tell the distance of an object. And having the Webb telescope and a telescope on Earth would allow us to pinpoint the trajectory of a Oumuamua-like object in 3 dimensions, very precisely, so that we can tell if there is any propulsion moving it, in addition to the sun's gravity that is acting on it. So that would be great, and I'm waiting for the next Oumuamua, and there would be this dating app called the Vera Rubin Observatory that will start operations in Chile within a year, and they will have a camera of 3.2 billion pixels, 1,000 times more pixels than in your cell phone camera. And it will monitor the entire sky, southern sky, every 4 days. And there is a very good chance it will find more objects like Oumuamua every year. And so we should just follow them. And most of the time we might swipe to the left. And every now and then we'll see an object that is of great interest. And we might even send a space mission with a camera close to it. So I'm just curious, and if it turns out that these are nitrogen icebergs, or hydrogen icebergs, or dust bunnies, so be it. We learned something new. These are rocks of a type that we've never seen before. And my cautionary tale is that if you imagine a cave dweller used to playing with rocks, finding a cell phone, the cave dweller will argue that the cell phone is a rock of a type that he had never seen before. And the only hope you have under these circumstances is that the cave dweller has a kid that would be curious and start to press buttons and realize that it's not a rock. So I'm this kid. That's basically it.
Thank you, Avi, thank you. And yeah, I think wonderful. So let's harvest the kid in all of us, and we look forward to hearing about how maybe we'll get you back here after you're in, was it Papua New Guinea? Is that where?
This summer. Yeah, I'll be glad to come in the fall and tell you what we found.
Excellent, and could be a very cool cell phone, apparently. All right, thank you, everyone.
That was